Find the 3-digit positive integer represented by a, b, and c, whose representation in base 9 is BCA, where a, b, and c are not necessarily distinct digits. Okay, so we're looking for an integer n, which is equal to, I'll write it the way they do. I've used this notation before as well. ABC, and that we want this to be equal to BCA. I'll be explicit that this is in base 10, and this is equal to BCA in base 9. Now it says that A, B, and C are digits, and the fact that we're representing something here in base 9 means I'm fairly confident that A, B, and C will be integers. Well, A, I'm sure, is not a 0. B is not a 0. I mean, technically you can still write stuff with a leading 0, but I don't think that's what they want us to believe. So A, B, and C are integers between 0 and 8, I would imagine, because the largest digit that occurs in a base 9 number is 8. So they're all between 0 and 8, pretty sure. And neither A nor B is equal to 0. Okay, now what does this mean? This means that 100A plus 10B plus C is equal to 81B plus 9C plus A. And we're looking for this number. They're not necessarily distinct digits. That's fine. Okay, well, let's rearrange this. 99A minus 71B minus 8C is equal to 0. From here on, it might just be a case of a little bit of brute forcing. Okay, so A is not 0. And B is not 0. And their numbers from 1 to 8. I suppose I'm just looking here at the difference between, so if A and B were both equal to 1, for example, they're both equal to 1, then this difference becomes 28, which is not a multiple of 8. What if I did something mod 8? If I just wrote down, if I wrote this equation mod 8, that's 0. Simplifies those a bit. Maybe we can solve for A and B. I'm going to try that so that I don't have to brute force so many different combinations. So if I mod 8 here, I get 19A minus 99 is the same as 80 plus 19. So that, this can be simplified further, of course. I'll do that in the next line. 72 is a multiple of 8. So this becomes 7b is equal to 0. And so I have, well, 0 mod 8. And what is this? 3a. 7 is the same as -1, so this is 3a plus b is equal to 0 mod 8. So this narrows things down, right? I can have A is equal to 1, and then B can be equal to 5. Could have A is equal to 2, and B is equal to 2. Are those the only cases that work? No. All right, if A is equal to 3, 9, so that becomes 9. I would need to add 7. B would have to be 7. So I guess there's a lot of solutions, aren't there, to this? But then when we go back to the original equation, there's a big gap between 99 and 71. Maybe this wasn't the best way to work it out. Right, I suppose every time we increase this by 1, we decrease this by 3 mod 8. And then okay. Well, some of these we might be able to sort of rule out. I've already ruled this one out actually from the original equation, right? Because 99, if A is 99, if A is 1, then I have 99. B must be equal to 5. That sum would be negative, and so we can't have this thing equaling 0. What about 2 and 2? So I have 99 times 2 minus 71 times 2 minus 8c is equal to 0. Also, by the way, before I go any further, I'm going to make sure I did this. 100 minus 1 is 99. 81 minus 10 is 71, so negative 71. 9 minus 1 is 8, so negative 8. Okay. What do we get here? 198 minus 142 minus 8c is equal to 0. 98 minus 42, is that 56? So c is equal to 7. Hold on. 99 minus 71, what did I say that was? That's 18. 18 wait, no it's not. It's 28. Either way, 1 and 1 doesn't work. It's not a multiple of 8. Oh, God. Okay, and yeah, okay. 28 is halfway between two multiples of 8. And so when we multiply by 2, it should be a multiple of 8. Yeah, my instinct was saying originally that this was not going to work because when A is equal to 1, when A and B were both equal to 1, this was not you know, this was not halfway between two multiples of 8. Anyway, it doesn't matter. I did the arithmetic wrong in my head earlier. This appears to be a solution. So the number should be 227. So let's check in base 9. We want the number 272 in base 9. This is equal to 2 times 81 plus 7 times 9 plus 2. So 81 times 2, 162 plus 7 times 9, 63 plus 2, 162 plus 65, 227. So this works. Yeah. I think this was a decent way to go. Write that equation out just by the definition of what we're looking for. If we mod by 8, that's gone, and we can quickly figure out, because we've modded by 8, and the numbers we're looking for, A and B, are supposed to be between 1 and 8, that kind of, in my mind, just like matches up what we're trying to do. So yeah, you can pretty easily write all the possible values of A and B that make this a multiple of 8. And then it's just a question of making sure that when you go back to not mod arithmetic, that they actually, that the difference between these is a multiple of 8, a positive multiple of 8, which, you know, doesn't require a value of C greater than 8. Anyway, we got there. That's my answer, 227, but I'll let you know if I have any mistakes. Thanks for watching.